Welcome to the video for C6.1.13, in which we're talking about different materials. So before we start, our usual quick recap of terms that we need to know before. So we've met the term conductivity before, both to do with heat and electricity. So if something's a good conductor of heat, it allows lots of heat to travel through it quickly. If something's a good conductor of electricity, then it allows electricity to pass through it well. And remember, the opposite term of this is insulator. So if something's a poor conductor of either heat or electricity, we'd call it an insulator. But the next terms are important to get correct, because people tend to use strength, hardness, and toughness interchangeably, and we need to make sure we use the right one. So hardness is how easy it is to scratch a material. So if something's hard, then you won't be able to scratch it easily. If something's not hard, then you can scratch it easily. Toughness is how much energy it takes to break a material with impact. So if I punched it or if I hit it with an object, if it was tough, then it wouldn't break apart. And then strength is a measure of how much force a material can be subjected to before it either breaks or it deforms. And there's two sorts that we need to be concerned about here. Compressive strength, which is how much force it takes when it's squashed an item for it to break or deform, or tensile strength, which is a measure of how strong it is when it's stretched. So they're kind of the opposite of each other. Right, if you're watching the interactive version of this, you need to just do the Office Forms quiz questions now. Okay, our learning objectives for today are to describe the typical properties of ceramics, and to use data to select material of particular use, which is something we've done before when we looked at metals and alloys, and also a little bit when we did polymers. And lastly, to use the structure of ceramics to explain their properties. So whenever we've done covalent compounds or ionic compounds on metals, we've linked their typical properties to their structure, and we need to do the same here. Okay, I'm going to skip over that slide because we've done it as the intro slide. Right, so what's a ceramic? So a ceramic is a hard, non-metallic material. So, quick reminder, we've already talked about it this lesson. Hard means it's not easily scratched. So typical examples of that are bricks, which are obviously used in a lot of houses and a lot of building and construction. China, which is used in plates. Glass, there's a jar there, but obviously we use it in windows, we use it in cups, it's in car windows. And then lastly, clay. So clay is quite soft when it comes out of the ground, but then we bake it and it turns into ceramic. And that's used in, you can see those plant pots there, but it's used in a lot of other stuff as well. And in terms of their structure, so ceramics can be either giant covalent or ionic compounds, but both of these have giant lattices of atoms, and that's what gives them their properties. So typical properties of a ceramic material are hard, so not easily scratched, brittle, which means, so it's the opposite of malleable. If you apply a force to it, then instead of deforming, it will break apart. They've got high melting points and they're stiff, which means they won't bend easily. And they're also poor conductors of electricity, so they're good insulators. So we need to link these to the structure of ceramics. So 1, 3, and 4, so the hardness, the high melting points, and the stiffness are due to high bond strengths between the atoms if it's covalent and between the ions if it's ionic. And that explains why they've got those properties. So the brittleness is because, unlike metals, so metals are the malleable materials that we've talked about before, and we know that in metals, the positive metal ions can slide easily over each other, and therefore it can be deformed. Whereas in giant covalent and giant ionic lattices, the atoms, if it's covalent, or the ions, if it's ionic, can't slide easily over each other without breaking apart the bonds. So they tend to be brittle. And then poor conductors of electricity is because there's no mobile charge particles. So to conduct electricity, we need some mobile charge particles. So either, in the case of metals, delocalized electrons, or if you've got a molten or dissolved ionic compound, the ions, mobile. So we can use our knowledge of the properties of ceramics to determine if metals are ceramics or not. So if we look at this table, we've got A, B, C, and D, and it tells us whether it conducts electricity, how hard it is, and the melting point. So if we think back to our previous slide about the properties, we can see, sorry, those arrows have not come up correctly. So material A, so conducts electricity. So we would expect that ceramics can't conduct electricity. So B can therefore not be a ceramic. In terms of hardness, we expect them to be hard. So C is not going to be a ceramic. And in terms of melting point, we'd expect all of them to have high melting points. So again, C is not going to be a ceramic. So if you look at all three of those properties, only A and D are going to be ceramic materials. Right, so the other bullet point that we needed to look at for our learning objectives was around this idea that we've done before of linking properties with uses. So here's an exam question. I apologise a bit for the bluiness. So the exam question says, police bullet-resistant vests could be made from either steel or Kevlar. And then we need to describe and explain 2 reasons why bullet-resistant vests are made from Kevlar instead of steel. So it's given us the properties there. It's given us the density, it's given us the relative strength, it's given us flexibility, and it's given the resistance to corrosion. So if we look at those 2 properties, we would want the density to be low, because remember, the density is the mass per volume. So if it's a high density material, then it's going to be heavy and uncomfortable to wear. We would want it to be strong, because remember, it's for a bullet resistant vest. So if a bullet is fired at it, we want it to be strong so that the bullet can't penetrate it. We would want it to be flexible, because it's an item of clothing that we're going to wear. So if it's not flexible, if it's stiff, then it's going to be uncomfortable to wear, and it's going to be more difficult to move around. And in terms of resistance to corrosion, then we'd want we don't want it to corrode, because otherwise we'd have to keep making new vests. If it doesn't corrode, then we can use it for a long time. So all of those points are summarized on here. So if we look at that, so actually for all 4 properties, this is unusual for these questions, normally they mix them up. For all 4 properties, Kevlar comes out the best. So we've said that the density needs to be low, otherwise it's going to be too heavy and uncomfortable to wear. So Kevlar is the least dense, so we can use that to answer the question. Kevlar is the strongest, so it's going to stop the bullet better than the steel. It's the most flexible, so it's going to be more comfortable to wear, and it's more resistant to corrosion, so it's going to last longer. So the exam question says describe and explain 2 reasons. So we just need to pick 2 of those, and because we've got describe and explain, we need to describe why that property, why Kevlar is the best. So for example, the density, the description is that Kevlar has a lower density, and then the explanation would be that that's because if it's a high density material, then it's going to be too heavy to wear comfortably. So I want you to use the same principles to have a go at this exam question. So this is task 1. So that's 4 marks, so it should take you 4 minutes to answer that exam question. You're then going to pause this video, because the mark scheme is going to come up on the next slide. Okay, so your second task is to mark your answer from your previous from the previous slide. Right, all you need to do now is, if you're watching the interactive version, is answer the Office Forms quiz questions on this lesson, which are just about to come up now. Okay, thank you for listening. See you next time.